Hi, welcome to solveandgo.com. In this video I'm going to continue with a series of videos giving solutions to the final exam for Math 135 in 2010. This video shows the solution for question number 9. So we're given a function, let f of x equals 3x to the power 5 plus 10x to the power 4 plus 10x cubed minus 2x plus 4. And then f is concave up on which interval? Okay, so for concavity, what we need to do is look at the sign of the second derivative. So let's get the first derivative. F prime of x is 15x to the power 4 plus 40x cubed plus 30x minus 2. And then the second derivative is the derivative of the first derivative. So this is 60x cubed plus 120x squared plus 30. And we need to test where this is positive and where it's negative. So we need to find out where it switches signs. So we're looking for possible inflection points, which means we should factor this. So we get 60 times, sorry, there's a slight error here. So, sorry, the line above, the first derivative, this is 30x squared. Okay, and so then we're left with this last term is 60x. Okay, so please make note of that error. In f prime of x, it was 30x squared was the second last term. Okay, so here is the second derivative. We're going to factor it. The common factor of 60x is what we'll factor out. So what we're left with is x squared plus 2x plus 1, which we can factor as 60x times x plus 1. And this is squared now. X plus 1 squared. Okay, so possible inflection points are when this is 0. Okay, so as you can see, there's 2, x equals 0, and x equals minus 1. So remember, an inflection point is a point where the sign of the second derivative changes. So these are potential inflection points. They're not necessarily inflection points, so we have to test that. Okay, so we have the possible inflection points. Let me rewrite the second derivative up a little higher to give myself some room. Actually, let's just erase the question. So remember, we're looking for where f is concave up. Just copy the second derivative again in its factored form. Okay. So we have our list of possible inflection points down here at the bottom. So what we're going to do is we're going to use test points to see what the sign is of the second derivative on given intervals. So the points we're concerned with are the possible inflection points. So that's x equals 0 and x equals negative 1. Okay, so we need to take test points in the intervals created by these possible inflection points. So we can choose pretty much anything we like. So let's choose negative 2 in this interval. In this one, let's choose negative 1/2. And above 0, we'll choose 1. Okay, so these are our test points. And we're going to see what the sign of the derivative is at the test point so that we can get the sign of the derivative on each of these three intervals here. Okay, so the first one going from negative infinity to negative 1, the second interval going from negative 1 to 0, and the last interval going from 0 to plus infinity. So I'm going to organize this in a table. Okay, so we have the test point, and then we have f double prime at the test point, and then down here we'll just keep track of the sign of the second derivative. Okay, so let's take the test point negative 2. We're going to plug negative 2 into the second derivative, And what you end up with, I don't have a lot of room to calculate this, but you can plug it in. It ends up being negative 120. Okay, so the sign here is negative. The next test point is negative 1/2. And again, I'm going to plug it in. What you end up with is negative 15/2. So again, the sign is negative. And then the last test point is x equals 1. Plugging it in and evaluating, you end up with 240, which is positive. Okay, so we see that from negative infinity to negative 1, the second derivative is negative, so it's concave down. From negative 1 to 0, the second derivative is negative, so it's concave down there as well. And it's concave up from x equals 0 onwards. Okay, so the conclusion here is finally, we just write out what we get. So we get that f is concave up on the interval from 0 to plus infinity. Okay, so that's the answer. We don't include the endpoint 0 because at 0 the second derivative is 0, so it's not positive, so f isn't concave up at that point. Okay, so it's just above 0 and up, 0 to plus infinity. And that's the solution to question number 9.